Good morning everyone and welcome to my YouTube channel. So here today we are going to be looking at the roots. Mostly we are going to be looking at the nature of the roots and also to find the value of any given value, knowing the nature of the roots. So firstly, under the nature of the roots, we have let's say for example we have an equation that is like this. Now here we are going to be looking at quadratic equations. Now let's say our quadratic equation passes like that. So now as you can see, the quadratic equation in this case touches the equation at 2 points. So now if the equation is touched at 2 points, this can be defined to be able to say that this one has got two real roots. So the roots are just the x values at where the graph touches the x-axis. So those 2 points are called the roots of the equation. Like let's say if here it is equal to 1, let's say here it is equal to -1. So this x is equal to -1 and our x is equal to +1. That's our root. So now what does this tell us? Now we know to say this equation, it is a quadratic equation in the sense that it will be given in the form ax squared plus our bx plus our c. So in such a case that this a could be any number, this b could be any number, and this c could be any number. But all in all, you will realize to say this is a quadratic equation. So with that said, we are going to be looking at the nature of the roots. Now, how do you find the x values at these 2 points? So by using the quadratic equation, knowing to say x should be equal to -b plus or minus the square root of our b squared minus our 4ac over our 2a, like that. So knowing that this is our formula of the equation, we are going to assume to say, now how do you determine the nature of the roots? Now the most important thing about knowing the nature of the roots is, do you know what your 4ac is equal to? Like for example, if you have let's say the square root of the b squared, let's say b squared, we have 6 squared like that, then we have minus our 4, then our a is 1, then our c is 9. So you're going to end up with let's say here we have plus or minus, b could be any number, such as let's say we have -9 here over our 2a. Now we are only interested in what will it give me at this point. So you will find that we are going to have a -9 plus or minus the square root of 6 squared gives us 36 minus 4 by 1 by 9 gives us 36 over our 2a. Now let's just focus on this. Okay, let's say my a is equal to 1 for the sake of simplicity. So now what you are going to find is that we are going to have a 9 plus or minus the square root of 36 minus 36 gives us 0 over a 2, like that. So now the square root of 0 is 0. So you are going to find that you are going to have -1 plus or minus 0 over 2. Now due to the fact that this is a 0, it simply means to say we are going to have repeated roots. Because what you are finding in the square root is equal to 0, that means to say you will only have one value that is going to come out. So therefore, this is where the discriminant comes from, to say if you have b squared minus 4ac is equal to 0, that means to say when you simplify your b squared minus 4ac, it gives you a 0. It simply means to say the equation has one repeated real root. So as long as we are looking at the situation whereby what is in the bracket here, it's more like equates to 0, like this, where we have the square root of 0. It simply means to say you have one repeated real root. So it is one repeated real root. like that. So 1 repeated real root. Now, with that said, the situation might be different where you have, let's say, your x should be equal to negative b plus or minus, let's say, whatever you get here. Let's say you have something like 25. Let's say we have a 50 minus a 4, then you have your AC like that. Okay, let's just say after you do your calculations, then we have here for AC is equal to, let's say, 25 like that, over whatever your 2a is. So here, to find the x value, you are going to find that you are going to have negative b plus or minus the square root of 50 minus 25 gives us 25. So the result for such a situation, we are going to have x should be equal to negative b plus or minus the square root of 25 is a 5. So now, due to the fact that let's just ignore whatever is here, due to the fact that you are going to have either x can be equal to negative b. We are just ignoring this. Let's just imagine that a is equal to 1 over 2 this point, so that it cancels there. But this is just for the sake of explanation, so that this one cancels. So it's either you have negative b plus 5, or you can have x should be equal to negative b minus 5. Now, due to this factor, it means to say, let's say our b is equal to negative 2 plus 5, or our x should be equal to negative 2 minus 5, which will be equal to a 3 here, or x should be equal to a negative 7 like that. Now, due to this factor, either you have your x is equal to 3 or your x is equal to negative 3. Then that means to say you have 2 real roots. In other words, as long as you have 2 different values of x, that means you have 2 real roots. Now, how is this brought about? So it means to say, as long as you have the discriminant to say b squared minus 4ac should be greater than 0. So in other words, whatever is in the square root, if it is greater than 0, you will always have 2 values. Let's say, for example, you have your negative b plus or minus, let's ignore the over 2a, the square root of any value that is greater than 0, such as even 1. You are always going to have negative b plus or minus the square root of 1 is 1 like that. So this is your x value. So either x is equal to negative b plus 1, or your x is equal to negative b minus 1. So always you are just going to be having 2 different answers for such a situation. So with that said, it means to say, as long as you have the discriminant, which we have said to say b squared minus 4ac should be greater than 0, then this means to say you have 2 real distinct, meaning to say different roots. So you will have 2 different roots like that. Now, in the same line, if you have an equation where you have your x is equal to negative b plus or minus, now whatever is in the bracket, let's say you have a negative 36, as long as you have a negative number, let's simplify it a bit. Let's say you have negative 1 for the sake of simplicity. So you will find that you're going to have negative b plus or minus the square root of negative 1 is I. So due to this factor that you are going to have, that you can say that either your x is equal to negative b plus I, or your x is equal to negative b minus your I like that. So now, with that said, you are going to find out to say these, as you can see, this is negative b plus I, this is negative b minus I. So as you can see, both of these values are conjugates of each other, because one is adding, one is subtracting. So you're going to say that a pair of conjugates. imaginary roots. So this occurs when the line does not touch the curve. So when the line does not touch the curve, then you will have a pair of conjugate imaginary roots. So this can be simplified by saying, as long as you have your b squared minus 4ac should be less than a 0, as long as whatever is in the bracket, your b squared minus 4ac for the quadratic equation is less than 0, then that means to say you are going to have imaginary roots, or in other words, they will tell you to say imaginary, or should I say no real roots. So no real roots simply applies to this conjugate, or rather it applies to this discriminant. So let's determine the nature of these roots. So to determine the nature of these roots, let's begin our solution. Firstly, we are going to have our a, which is our 4x squared minus 7x minus 1, like that. So to determine the nature of the roots, we are going to say, using the discriminant b squared minus 4ac, and find out what this can give you. Now, for any given quadratic equation, it is always known to say this one, the one with where it is attached to x squared, that's your a, the one with just x, that's your b, the one with just without c, that's without x, that's your c, like that. So we are going to have b is -7, so we are going to say -7 squared, then we are going to say minus 4, our a is equal to 4, then our c is equal to -1, like that. Find out what it is giving you. -7 squared, if it is in bracket, it will be positive 49. If it wasn't, we are going to have -49. So we are going to have minus -4 times 4, it is -16 times -1, it will give us a positive 16, like that. So adding our 49 plus 16, this will give us a value that is equal to a 64, like that. Now this one is our discriminant. So the discriminant is the value which is this one, our b squared minus 4ac, that's our discriminant. So discriminant is equal to 64. Sorry, not 64. 16 plus 49 gives us 65. So our discriminant is such that it is equal to 65. Now if you see this value 65, you will realize to say it is greater than 0. So if it is greater than 0, it means to say as long as you have a number that is greater than 0, you will say two real distinct roots, meaning to say two real different roots. That means to say you have solved that one. When we look at our b, which is saying that we have our 5x squared, so we have our 5x squared plus our 2x plus our 1. So this is our a, b, c. So we are going to be able to say b squared minus our 4ac should be equal to 0, like that. So what we are going to have is that our b is 2, so we have 2 squared minus 4. Our a is equal to 5. Our c is equal to 1. So this one will give us a value of sorry, not should be equal to 0. What did I write here? Okay, yeah. So you use your discriminant d, which is equal to that. So simplifying this, we are going to have 2 squared will give us 4. Then we have minus our 20, like that. So when you subtract 4 minus 20, this gives us a value of negative 16. Now if the discriminant is negative 16, you will say that negative 16, you know that negative 16 is less than 0. So if it is less than 0, you will be able to say the nature of the root is a pair of conjugate complex roots, like that, or just no real numbers for that case. So for this one, same approach. This is our A, this is our B, this is our C. So B squared minus 4AC should be equal to, we find out what it is going to give us. So the discriminant should be equal to, our B in this case is equal to negative 30. We square this minus our 4, our A is equal to 25 times our C is equal to positive 9, like that. So negative 30 squared, this will give you positive 900. Then we have minus, let's just multiply first, our 4 times 25. 4 times 25 gives us 100. Then we have times our 9, like that. So this gives us a 900 minus 900. So our discriminant is such that discriminant is equal to 0. So since your discriminant is equal to 0, what you are going to say that is that you have one repeated real root. So let's advance questions a bit. It says that find the value of k for which the line x plus y should be equal to k is a tangent to the curve. So it is a tangent to the curve. Now remember, if we have a curve like this, let's say we have a curve like this, it could be anything. Now okay, let me remove this. If we have a curve like that, a tangent is a line that touches the curve at only one point. So now that means to say this one is already one repeated root because it is a line that touches the curve at only one point. So that is what a tangent basically is. So now what we are going to do is that we are going to get both of these equations. So for one equation it says x plus y should be equal to k, like that. Then for this other one, it is saying that we have our x, open brackets, we have our x minus y, then we have plus our 2, like that. So this should be equal to 0 according to what we have been. So remember, they want us to find the value of k. So we get both of these equations. What we are going to do is that since there is only one y in this equation, make sure that you make y the subject of the formula in this other equation. So what you're going to have is for x plus y should be equal to k, you take the x this side, so that you are going to have your y should be equal to k minus x, like that. So what we are going to have is that our x, then we have open brackets x minus, where there is y, we are going to put this value, which is our k minus x, like that. So after that we have a plus 2 should be equal to 0. So we are going to have our x like that, negative times positive k, it will be negative k, negative times negative x, it will be positive x, like that. Then we have plus our 2 should be equal to a 0. So we are going to have our x like that. X plus x will give us a 2x. Then we have minus our k, like that. So x plus x gives us a 2x. So minus our k, like that. Then we are going to have plus our 2 should be equal to 0. Then the next stage is that we are going to open the brackets. So x times 2x, this will give us 2x squared. Then we have minus our x times k, it will be negative kx. Then we have plus our 2 should be equal to 0. Now remember, we said that this is a tangent, meaning to say it touches the graph at one point, meaning to say it only has one root. So therefore, we are going to say that we are going to use the discriminant b squared minus 4ac should be equal to 0. And we know that. So from this equation, this is our a, this is our b, this is our c. So what we are going to have is our b squared. We are going to say negative k squared like that. Then we have our minus our 4, our a is equal to 2, our c is also equal to 2, should be equal to 0. So we have negative k squared is k squared. Then we are going to have minus 4 times 2, that's 8, times 2, that's 16. So minus 16 is equal to 0. So we are going to have our k squared should be equal to positive 16. So when we find our square root of both of these numbers, we are going to have k should be equal to plus or minus 4 like that. So it's either k is equal to 4 or k is equal to negative 4. So let's say for what values of w will the function f of x cut the x-axis? So when it cuts the x-axis twice, that simply means to say we have this type of a situation where we have the equation passes and it has got 2 points like that. So now, due to this factor, we have the equation that is looking like that, passing at this point and also passing at this point. So this is what it means. It cuts the x-axis at 2 points. So now with that said, we are going to use the discriminant that accounts for 2 real solutions. So we are going to say our b squared minus our 4ac should be greater than 0. So remember, we have the equation which is our f of x. So the given equation is f of x is equal to x squared plus 6x plus our w. So this is our equation. So for the first part, which says that cuts the x-axis twice, we are going to use this discriminant, and it shall be, so we have our a, we have our b, we have our c. So we are going to say that where there is b, we are going to put our 6 squared, because b is equal to 6, minus our 4. Our a value is the coefficient of x squared, which is 1 in this case. So we are going to say times our 1 times our c, which is a w, should be greater than 0. So we are going to have 6 squared gives us 36, minus 4 times 1 times w, it will be 4w should be greater than 0. So we take the 4w the other side, we are going to have 36 should be greater than our 4w over our 4 over our 4. We are going to have our 9 should be greater than w. So now if you decide to take the 36 there, it will be negative 4w should be greater than, then the 36 goes the other side, it will be negative 36 there. If you divide negative 4, it will be w. Then since you're dividing by a negative, it will change direction and say 9, which is the same. When you say w, 9 is less than w, or sorry, 9 is greater than w, or when you say w is less than 9, it's still the same. So now the other part, it says that we are going to be looking at it touches the x-axis. If this equation touches the x-axis, what it means to say is that when we just say touches the x-axis, it means to say it does not cross the x-axis but touches. It's possible that your graph might be at this point, but the main thing is that it just touches the x-axis like that. It might be anywhere. It might be here, it might be here to just touch the x-axis like that. It might also be upside down where we could have something like this. So as long as your equation touches the x-axis, it simply means to say it only occurs at one point where it touches the x-axis, just one point. So it could be this, it could be this, it could be this type of a situation. Therefore, the discriminant that describes this is when we say b squared minus 4ac is equal to 0 for the equation which is saying that y should be equal to x squared plus 6x plus w. So we are going to have our b, which is equal to a 6 in this case. So this is our a, b, and c. So it will be b squared minus our 4, our a is equal to 1, which is the coefficient there. Then our c is equal to w should be equal to 0. So we are going to end up with 6 squared is 36 minus our 4w should be equal to 0. We take the 4w the other side, so 36 should be equal to 4w over 4 over 4. So our w value will be equal to positive 9 like that. So for the last condition, if this equation has no x-intercept, it simply means to say it will more like just occur away from the x-axis. Now, due to that factor, the only intercepts that this one would have are imaginary, or rather those intercepts do not exist. Therefore, the discriminant for this will be b squared minus 4ac should be less than 0. As long as you have a root, no real roots, you are going to be using this because this equation does not touch the x-axis. So we are going to say our b squared, which is in this case the equation is y should be equal to x squared plus 6x, then we have plus our w. In this case, what we are going to have is our b is 6 squared minus 4, our a is 1, then our c is equal to w should be less than 0. So we have a 36 minus 4 times w, it will be 4w less than 0. So we are going to take the 4w the other side, so we have 36 should be greater than, we take it there, it will be 4w over 4 over 4. We are going to end up with 9 is less than our w. So this is our last solution for that one. Let's look at the next question. This one says that the equation x squared minus open brackets p plus 2x plus p squared plus 3p should be equal to 3 has real roots. So now this one is just saying that has real roots. So we don't know whether it has got one repeated roots or it has got two different roots. So what we are going to do is that, so this could either be one repeated real roots, or it could be two distinct roots, but we don't know. So what the discriminant that we are going to use for that, we are going to say b squared minus 4ac should be greater than, that's the discriminant for if we have the condition whereby it has got two distinct roots. Then for this one repeated root, because it's possible that it could have one repeated real roots, so that means to say we can put an equal sign like that, equal to 0. But instead of writing like this, that's not how we write. To combine, we are just going to put this thing. So b squared minus 4ac is greater than or equal to 0. So the equation is such that we have our x squared minus our p plus our 2, then we have our x, then we have our p squared, then we have plus our 3p should be equal to 3 like that. So let's first simplify. So we are going to have our x squared, then multiply this x throughout. It can be written as negative x open bracket p plus 2, just putting it in front there. then we have plus our p squared plus our 3p. This 3 comes here, we have our minus 3 should be equal to 0. So what we are going to end up with is our x squared, then negative x by p, it will be negative px, negative x by 2, it will be minus 2x, then we have plus our p squared plus our 3p minus 3 should be equal to 0 like that. So what we are going to end up with is remember, whatever has got x to the power 2, that's your a. Then whatever has got just x to the power 1, that's your b. So this is our b, whatever has got just x. Then whatever doesn't have x, that's our c, like that. So when we do that, we are going to end, let's use now our discriminant, b squared minus 4ac should be greater than or equal to 0. So our b squared is equal to our negative p minus 2. So you just get the coefficients that are there. So we have minus p and negative 2, the numbers attached to x. Then we have squared there. Then we are going to say minus 4. Then our a value has got the coefficient of 1. So we are going to say 1 there. Then we are going to put here, we are going to put 1 times, that's our a, times our c, which is our p squared plus our 3p minus 3, which should be equal to a 0. So we are going to expand this. So this is the same as having our negative p minus 2, another one, negative p minus 2. Then we are going to have minus 4. 1 times this, 1 doesn't change anything, so it will still come back to p squared plus our 3p minus our 3, like that. Then this one should be equal to 0. So let's multiply. To multiply this, we get the negative p multiplied by negative p minus 2. Then we have minus 2. Get this first number, multiply everything here. Then get this second number, multiply everything there. So we have a negative p minus 2. Then we have negative 4 times p, it will be negative 4 p squared. Negative 4 by 3p, it will be negative 12p. Negative 4 times 3, it will be plus 12, should be equal to 0. So we are going to end up with p times negative p times negative p, it will be positive p squared. Negative p times negative 2, it will be plus our 2p, like that. Negative 2 times negative p, it will be 2p. Negative 2 times negative 2, it will be a 4. Then we have minus our 4p squared, then minus our 12p, then we have plus our 12 should be equal to 0, like that. Then we are going to simplify where possible. So you will find that this p squared and our negative 4p squared are the same. So p squared minus 4p, it will be minus 3p squared, like that, as our value there. Then we have our 2p plus 2p. This will give us a 4p. So let's just simplify. 2p plus 2p, that's 4p. Then minus 12p. This will give us a value of a negative 8p. So 2p plus 2p, that's 4p minus 12p, that's 8p. Then we have plus our 12 plus this 4. So 12 plus our 4 there, it will give us a positive 16. Should be equal to a 0. Sorry, from there, we were not supposed to be using an equal sign. So you can just change greater than or equal to. Should be the sign we should be using, unless if we are sure that it is just one repeated roots. So we have should be greater than or equal to 0. Even here you put greater than or equal to 0, greater than or equal to 0, greater than or equal to 0. Now this is a quadratic. That simply means to say we are going to find our critical values. So critical values are the zeros of the equation. So critical values will be such that we are going to be having a situation of, we just get this equation, negative 3p squared minus 8p, then plus 16. You equate it to 0 to find the critical values. And then what we are going to have is that we have, this is a quadratic equation, so we have our product should be equal to AC, which is equal to our A is this is our B, this is our C. So our A is negative 3 times, our C is 16. So negative 3 times 16 will give us negative 48. Then when we look at our sum, which is the coefficient of B, which is equal to negative 8. So if we have our factors, which are two numbers, when you add them, they are going to give you negative 8. When you multiply them, they are going to give us negative 48. These values are, one of them should be such that we are going to have a negative 12. The other value should be a positive 4, like that. If I add this, I'm going to get that. If I multiply them, I'm going to get negative 48. So with that said, where there is b, we are going to replace these values. So we have a negative 3p squared, then we have minus 12p, like that. Then we have plus our 4p also. Then we have plus a 16 should be equal to 0. We are finding our critical values. So factorize, negative 3p is common here. Then we are going to have our p. We are remaining with a p. If we get 1p, we are remaining with a p. This and this goes. So we have plus our 4 there, because negative 3 divided by 12, negative 12 is a 4. Then we are going to have plus, where 4 and 16, 4 is common. Then we are going to also have, we are remaining with a p here. 16 divided by 4 will give us a positive 4 there, should be equal to 0. So the brackets are the same. We can have p plus 4 and negative 3p plus our 4, which should be equal to 0. So we equate either p plus 4 is equal to 0, or we have a negative 3p plus our 4 should be equal to 0. So our p should be equal to, we take it the other side, it will be equal to negative 4, or we have our negative 3p, we take it the other side, we have should be equal to negative 4 over negative 3 over negative 3. So our p value will be equal to positive 4 over a 3, like that. After finding our critical values, we are going to draw a number line, and we are going to say that we have a negative 4 here. We also have a 4 over 3. We know that 4 over 3 is greater than negative 4. So we have regions, different regions. At this point, all the x values that are this side are greater than a 4 over 3, because if you are looking, as you move to the right, the values increase. Then when you look here, you have all the values that are this side. They could be negative 5, it could be negative 6, but we are interested in our boundary, which is our negative 4. In other words, all the values as you move to the left, they are less than our negative 4, like that. Then what we are going to have in the middle, it's an interval such that we have values, negative 4 is less than x, because all the values that are in between these, like the value that could be here is a negative 3, which is greater than negative 4. So negative 4 will always be less than your x value. Your x value could be any value such as 0, 1, 2. Then we are going to say it should also, but this x value should also be less than the last boundary, which is this one. We are going to say our 4 over our 3, like that. So if we have this, we can just come up with a sign table real quick. So we have, just in case you haven't watched that video, kindly comment so that I can forward you the link. So we are going to say our factors using what we factorized. We have a p plus 4 and a negative 3p. So we have a p plus our 4. The other factor is such that we have a negative 3p, then we have plus our 4 like that. Then what we are getting, since these are in one bracket, p plus 4 times our negative 3p plus 4, you will find that the multiplication between these two is what we are going to be calling a product like that. Then we are going to say, just take whatever you wrote here from the number line. We have our x is less than negative 4 like that. For the other one, which is our interval, we have this one. Our negative 4 should be less than x. At the same time, x should be less than 4 over 3. Then last but not the least, we are going to have our x is greater than our 4 over 3 like that. Then we have our product. Now if x is less than negative 4, it means to say x can be a value such as a negative 5, because this value is less than negative 4. In between negative 4 to 4 over 3. 4 over 3 is approximately equal to 1.33. So x here could be, if you want, you can use negative 3, but for the sake of simplicity, I'll use 0. You can use any value that is in between this range. Then if x is greater than 4 over 3, and if 4 over 3 is equal to 1.33, so you can actually simplify this, so it will be 1 point, so the remainder is 1. You add a 0, it will be 3. So that's how come I said 1.333. So now, if that's the case, x could be equal to a 2. Then just replace. If I put negative 5 here, I'm going to have a negative value. If I put negative 5 here, it will be negative 5 plus 4, which is equal to a negative 1. So I'm just going to write a sign. Then if I put negative 5 here, it will be my negative 3, where there is p, I'm going to put negative 5 plus 4, which should be equal to negative 3 times negative 5, it will be a 15 plus 4, which shall be equal to positive 19. So the fact that it's positive, I'm going to just say positive. Then we are going to multiply product, negative times positive, it will be equal to a negative like that. When we get our 0, we put it here, it will be 0 plus 4, which is equal to 4. So we are going to have a positive. If we put 0 here, it will be a 0. This whole thing will become 0. So it will be positive, and finally positive here. Then when we look at the range here, it's giving us that our x is equal to 2. So when we put our 2 here, it will be 2 plus 4, which is equal to 6, which is a positive. When we get our 2, we put it here, it will be our negative 3, where there is p, we put 2 plus 4, which is equal to negative 6 plus 4, which is equal to negative 2. So negative 2, so we are going to say negative. Positive times negative, it is going to give us negative. So now, the condition is that the product should give us something that is greater than or equal to 0. Remember, what was in the bracket was a p plus our 4 and our negative 3p plus our 4 should be greater than or equal to a 0 like that. So if that's the case, we should have the product, which is after you multiply these two brackets, you should have a value that is greater than or equal to 0. So therefore we are going to find our product, which is greater than 0, which in this case is a positive. If you look at this, they are saying that it should be greater than or equal to 0. So we take that as our answer, which is saying that negative 4. So we have negative 4 less than x less than 4 over 3. But remember, it's saying or equal to, so we are going to put that. So this is our answer for that problem. So let's look at our B. We have find the values of t if the equation a squared x squared plus ax plus 1 is equal to 0 can never have equal roots. That means to say it can have 2 real roots two real distinct, meaning to say two real distinct or different, or it could have just no real roots. That's the meaning. So the only condition is that this equation must not have equal repeated roots. So now I think there's a mistake on t. Let's imagine that here there was a. So what we are just going to say is that we have our equation which is saying a squared x squared plus our a x plus 1 should be equal to 0. So the one with x squared will be our a, the one with just x will be our b, and the one without x will be our c. So what we are going to have is that we are going to say our b squared minus our 4ac. It could be greater than, it could be less than minus 4ac. We are just going to say should just not be equal to a 0, because this is the one that gives equal roots, or rather repeated roots. It is when b squared minus 4ac is equal to 0, but we are just going to say should not be equal to 0. So what we are going to have is our b is this a, so we are going to say a squared minus our 4. Our a in this case is equal to a squared, like that. Then our c is equal to 1, should not be equal to 0. So we are going to have our a squared, then we are going to have minus our 4 times a squared times 1, it will be 4a squared, should not be equal to 0, like that. So after doing that, we are going to end up with a squared minus 4a squared, it will be negative 3a squared, should not be equal to 0. We divide negative 3, we divide negative 3, we are going to find that our a squared should not be equal to a 0 divided by negative 3, it will be a 0, like that. Then we find the square root, it will just be a should not be equal to 0. So this is the condition. A should just not be equal to 0. It could be less than 0, it could be greater than 0, but the main thing is that it should not be equal to 0 in that case. So if we have our c, which is saying that x squared plus our t minus 2 x plus 10 minus our t should be equal to 0, has equal roots. So they have given us the roots that it has equal roots. So we are going to first simplify. So we have x squared plus this x times t, it will be tx. This x times 2, it will be minus our 2x. Then we are going to have plus our 10 minus our t should be equal to 0. So we are going to now arrange. So this one, the one with x squared, that's our a. The one with just x to the power 1, that's our b. Then finally the one with without x, that's our c, like that. So if that's the case, what we are just going to end up with is since we have been told that has equal roots, so we are going to use our b squared minus our 4ac should be equal to 0. Our b is we have a t in this case minus a 2. We square this, then we have minus our 4. Our a has got the coefficient of 1 there, so we are going to put a 1 times our c, which is our 10 minus t, which is equal to 0. So we have t, for expanding this, so we have a t minus 2 minus 2, t minus 2, then we have minus 4. 1 doesn't change anything, so this will return, it will be a 10 minus t, like that. Then this should be equal to 0. So let's expand. We have this times this, t squared, this times this, it will be minus t, this times this, we have minus, like that. This times this, we are going to have plus a 4. Then we have our negative 4 there, then we are going to have times, let's multiply. So we have negative 4 times 10, it will be negative 40. Negative 4 times t, it will be plus 4 t, which should be equal to 0 like that. So after we do that, let's just simplify where possible. So we are going to have our t squared, then we have our negative 4t like that, then our 4 minus 40, this will give us a negative 36, then we have plus our 40 should be equal to 0. So negative 40 plus 40, that's 0. So therefore our equation will be t squared minus 36 should be equal to 0. So our t squared should be equal to, we take the 36 here, we are going to be having, let's find the square root. So our t should be equal to plus or minus 6. So either t is equal to 6 or t should be equal to negative 6 like that. Let's look at our last question. For what values of n will the x-axis be a tangent to the curve? So if we have our f of x should be equal to nx squared, then we have plus our 1 plus our n, then we have our x, then we have plus our n like that. So let's just first simplify. So we have nx squared, this x times 1, it will be plus x, this x plus n, it will be plus nx, then we are going to have plus our n like that. So already this is your a, then the one with x, this is your b, then finally this is our c. So we are going to say b squared minus our 4ac. If it is a tangent, means it touches the curve at one point, should be equal to 0. So we are going to have our b squared, which is the coefficients. So we have a 1 in front and an n here. So we are going to have 1 plus n minus our 4. Then our a is n, then we have times our c, which is our n as well in this case. So we are going to have this should be equal to 0. So we have a squared here. So expanding this, 1 multiplies everything, and also n multiplies everything, which we have worked with. We have minus 4. N times n is n squared, which we can just write here since there's only one number there. So we have n squared like that. 1 times 1, it's a 1, plus 1 times n is equal to n. N times 1, it is equal to n. N times n, it will be equal to n squared. Then we have minus 4n squared should be equal to a 0 like that. So to simplify this, we are going to have n squared minus 4n squared, it will be equal to negative 3n squared. Let's begin with that. Then n plus n, it will give us plus our 2n. Then we have just plus our n. I've just reordered it. Should be equal to 0. So this being a quadratic, we are going to have our product, which is equal to AC, which is equal to negative 3, times positive 1, which is equal to negative 3. Our sum, which should be equal to B, which is equal to 2. So I'm just being fast. So then our factors, two numbers, which when we add them, they're going to give us 2. When we multiply them, they're going to give us the product, which is our negative 3. In this case, it will be positive 3 and a negative 1. So get this, put them where this is. So if I add these, I'll get positive 2. If I multiply them, I'll get my negative 3. So it will be negative 3n squared. Then we have plus our 3n minus n plus 1 should be equal to 0. So we are going to have a situation whereby we have factorizing this separately. So we have a negative 3, n is common. So we are remaining with n plus our 3 like that. Then we are here, instead of saying plus, it will be a minus because the negative is out here and it divides negative 3, it will be negative. Then here what is common is we are going to take our negative 1. So just tired, we have minus 1 because negative 3 divided by 3 is negative 1. Then we have open brackets, n will be positive since we take out the negative, then this one will be negative, like that should be equal to 0. So in one bracket it will be n minus 1, in another one it will be 3n minus 1, which should be equal to 0. So either n minus 1 is equal to 0 or negative 3n minus 1 is equal to 0. So our n value is equal to positive 1, or our negative 3n should be equal to positive 1. We divide by negative 3, our n value should be equal to negative 1 over 3. The other n value is equal to 1. Since we have two different n values, so what we are going to have is that for our equation was given as, we have our f of x is equal to nx squared, then we have plus our 1 plus our n x, then we have plus our n, like that. So when n is equal to 1, what we are going to have is f of x should be equal to, where there is n we put 1, so it will be 1x squared, so we don't write the 1 there. Then we have plus our 1, where there is n, plus our 1 plus, where there is n we put 1. Then we have our x plus, where there is n we put 1 for this equation. So it will be x squared plus 1 plus 1 is 2. Then outside there is x plus 1. So this is how we go about that one. So when x is equal to 1, that's our value. Then when our x is equal to negative 1 over 3, which is the value we have found, so our value will be equal to, using the same equation, so we have our f of x should be equal to, we have our x squared, so where there is n, we are going to put negative 1/3. So our f of x should be equal to, where there is n, we are going to put 1/3 x squared. Then here we have 1 plus, since it's negative, so it will be minus 1/3. Then we have our x, then we have plus our, now since it's negative, it will just be minus 1 over 3. So after doing that, we are going to have negative 1 over 3 x squared, plus, we are going to have plus, our common denominator here is 3, so we have 3 divided by 1, that's 3 times 1, it will be 3 minus 1 there. Then we are going to have our x minus 1 over 3. So the other equation is this one, like that. 3 minus 1 gives us a positive 2 over 3x, then we have 1 over 3, like that. So this is the equation of f of x. So it's either x is equal to this, or another one, our x is equal to, which was the first equation we wrote, our x squared plus our 2x plus 1. So that's how you go about that. So if you're asked such a question, you will have to write both of the equations unless you are given any other condition. So this is how you go about it. See you in the next tutorial. Hope you would like, subscribe, and share for more.